Hi, my name is Amr Goma and I'm a doctoral candidate at the German Research Center for Artificial Intelligence and Saarland University. Today I'm going to talk to you about our work that relates to adaptive user-centered neuro-symbolic learning. So the motivation behind this work is that existing machine learning-based methods usually perceive and comprehend objects and environments in a perceptual subsymbolic manner, meaning that with the advances of LLMs and computer vision approaches, it's mostly a data-driven approach. However, we argue that we need a hybrid learning approach that can combine both symbolic and subsymbolic learning to allow for autonomous systems to understand objects on both conceptual and perceptual manner. And to achieve so, we need these learning methods to consider both implicit feedback that they are getting from the sensors from the user, as we can see here through observations, as well as explicit feedback that the user can do some intervention and start teaching the model. And by doing some adaptation from the model side to these interventions, the model can now learn in a both symbolic and subsymbolic manner through its knowledge base that it gets from the user or from different users, and its sensors, which are the data-driven approach. And we also argue that we need a multimodal output devices that can give several modalities for users when presenting with the output of the model. And to achieve that, we propose several research questions. The first one is how can the agent perceive the world around it and what is its view? Here the agent we are talking about the autonomous system. What is the context that it can learn from and what is the behavior of the users that it can see and how can it detect and classify these different situations. And we're also talking about the different modalities when we talk about the devices or the sensors, and then how can this be efficiently provided to the system to conclude with its solution. Another aspect is the multimodal interaction or the multimodal fusion in both the input and the output. How can we design the system to be adapted to what's happening in a temporal manner or to achieve optimal performance as well as achieve the best outcome that goes to the user? And when talking about adaptation, then it's important to talk about the learning algorithm. So instead of relying on rigid fixed learning algorithms that can do all of this at once and modeled as a one-size-fits-all and very huge one, we argue that we should have adaptive methods that can be continuously learning from user feedback and user changing behavior. By continuously gathering this feedback and using incremental learning and transfer learning approach, we can adapt, or the system can adapt to user behavior. And thus our proposed solution has several aspects or several facets. And the first one is that we need to understand the user, and this is the first stage. So in our previous work, we relied on user observation to come up with the different behavior or to see the different aspects in which user behavior change. And based on that, you can come up, or the system could automatically come up with different multimodal fusion approach that relies on hybrid learning or relies on clustering the users into several clusters and then opting the appropriate output for each user, but also using the appropriate model for each of this personalized behavior. And thus it goes to the third part, which is personalized adaptation and continuous learning, where we propose several methods to learn different models for each user instead of one model that fits all sizes. And we rely on transfer learning and incremental learning techniques to adapt to different user behavior. And you can read more about that in our previous work and also in our paper where we highlight and propose the different solution in it. And just to conclude, we want to highlight that there is no global solution that fits all users because users behave very differently, and that's what we have seen in human-computer interaction. And while current data-driven approaches can rely on implicit feedback, we want to benefit from explicit feedback in a hybrid learning manner, and that's what we are proposing in this work and hinted in a previous work. However, we need more continual learning methodology that can adapt to the changing user behavior, and that's what we are arguing for. And then thank you for listening. So please reach out to me. Here is my email, and you can find my handle as the same handle for Facebook, LinkedIn, and Twitter. And thank you again for listening.